4 astronauts, 1 spacecraft, and something nobody on Earth was prepared for. Before we get into what actually happened, quick question. Where in the world are you watching this right now? Drop it in the comments. I'm genuinely curious. Now, back to what I was saying. Because here's the thing. When Artemis II swung behind the moon, something happened that changed how every single scientist, every engineer, every person planning to send humans to live up there, changed how all of them see that silver disk in the sky. And I'm not going to tell you what it was yet. I want you to sit with it, because when we get there, at the very end of this video, it's going to hit completely differently than if I just told you now. So stay with me, because this one builds. Let's rewind. November 2022, NASA launches Artemis I, unmanned, a test run. It loops around the moon, comes back, splashes down in the Pacific. Success. Then comes Artemis II. 4 astronauts, Commander Reed Wiseman, pilot Victor Glover, mission specialists Christina Koch and Jeremy Hansen, the first humans to leave low Earth orbit since 1972. 50 years, half a century, and now they're back. But here's what most people missed about this mission. It wasn't a landing. There was no moonwalk, no boot prints in the dust. The entire point of Artemis II was to prove the hardware works before you trust it with something bigger. Check the life support, test the navigation, make sure 4 human beings can survive deep space and come home alive. That was the plan. But space has this habit, this extremely inconvenient, extremely fascinating habit of handing you something you never asked for. And on April 6, 2026, as Orion swung around the far side of the moon, the solar system handed the Artemis II crew something nobody had ever seen before. Here's what made that moment so geometrically perfect and so completely unrepeatable. The moon slid directly between the spacecraft and the sun, not from Earth's perspective, from behind the moon itself. The crew was sitting in the moon's own shadow, looking back toward the sun, watching the solar corona, that massive halo of superheated plasma that surrounds the sun, blaze outward around the black silhouette of the lunar disk. No atmosphere between them and it, no humidity blurring the edges, no scattered city light bleeding into the frame. Just vacuum and light, and a black circle of a world hanging in front of a star. Wiseman would later describe it as transcendent. He said the corona stretched outward what appeared to be 10 solar diameters. Filaments, structures, things you cannot see from the ground no matter how perfect your eclipse is, because you are always looking through 100 kilometers of air that is quietly stealing the finest detail from everything you try to observe. The crew was seeing the sun the way the sun actually looks. But then, while that corona burned in silence behind the rim of the moon, something else caught their attention. Down on the dark surface below them, flashes, short, sharp, bright. Not reflections from the spacecraft, not sensor glitches, not instrument noise, something else entirely. And that is where the story really begins. Here is what you need to understand about the moon before we go any further. The moon has no atmosphere. None. The total mass of everything gas-related surrounding it is about 10 metric tons. Earth's atmosphere is 5 quadrillion metric tons. The moon's version is, for any practical purpose, nothing. A ghost. A rounding error. What that means is simple and terrifying. Anything that approaches the moon from space arrives at full speed, unslowed, unheated, unbroken. No compression, no plasma column, no burning up 60 miles above the surface and becoming a pretty streak of light you wish on at summer camp. On Earth, a grain of sand-sized rock traveling at 40 kilometers per second hits our atmosphere and vaporizes before it gets anywhere near the ground. That's what a shooting star is. The rock never touches anything. The atmosphere eats it alive. On the moon, that same grain of sand hits the surface at full cosmic velocity. We're talking anywhere from 11 to 70 kilometers per second depending on where it came from. And when something moving at 70 kilometers per second, that's over 156,000 miles per hour, hits solid rock, It doesn't bounce. It doesn't crack. The contact point becomes plasma. The surrounding material vaporizes in milliseconds. A shock wave blasts outward through the regolith, a crater forms, and for a fraction of a second, there is a flash of light. That is what an impact flash is. Now, NASA has a program called ALAMO, the Automated Lunar and Meteor Observatory, that has been watching for these flashes since 2006, nearly 2 decades of careful, patient, systematic observation using telescopes in Alabama. Their long-term average? About 20 confirmed impact flashes per year. 20 in 12 months. The Artemis II crew saw 5 or 6 in 60 minutes. Now, before that number runs away from you, there are caveats, important ones. The Alamo system watches through Earth's atmosphere from 250,000 miles away, only during specific lunar phases, only during clear nights, only when the moon is at a useful elevation above the horizon. Stack all those constraints together, and the actual usable observation time shrinks dramatically, and anything too faint to survive that journey through the atmosphere simply disappears into noise. It happened. The moon was struck. Nobody recorded it. The Artemis crew had none of those limitations. No atmosphere, close range, full lunar darkness created by the eclipse, maximum contrast between flash and background. They were seeing flashes far too faint for any ground-based system to ever catch. But here is what makes planetary scientists so unsettled when they look at this honestly. Even if you discount the Artemis observation heavily, even if you assume half of what they saw was boosted by those exceptional conditions, or that a passing meteoroid stream temporarily elevated the rate, you still end up with a detection gap that isn't twice the ground-based number. It's not 10 times, it is orders of magnitude higher. The theoretical models built on orbital particle detectors and crater-sized distribution data have been pointing to this for decades. They've been telling us the true impact rate is thousands of times higher than what any ground-based system records. We just never had a human observer in position to confirm it with their own eyes. Until April 6th. And here's the number that should stop you cold. A recent study estimates that a lunar structure with an exposed surface area comparable to the International Space Station would be struck by between 15,000 and 23,000 micrometeoroids every single year. 23,000. Not a dramatic one-time event, not a crisis you plan around and move on from. A permanent, invisible weather system. Particles the width of a human hair moving at 20 kilometers per second, each one punching a microscopic crater into whatever surface they hit. Thermal blankets, solar panels, structural joints, pressure seals, silently, constantly, without any warning, accumulating damage that no sensor will ever flag until something fails. This is the world we want to build in. And one of those impact flashes that the Artemis crew reported, at least one occurred near the lunar South Pole, the exact location where NASA, ESA, and multiple international partners plan to build the first permanent human outpost beyond Earth.
So here we are. You've been waiting for this. The thing I told you about at the very beginning. The thing the Artemis II crew saw behind the moon that nobody on Earth was prepared for. It wasn't a discovery of something new. That's the part that changes everything. What the Artemis II crew saw was something old, something ancient, something that has been happening every hour of every day for 4.5 billion years. They saw the moon the way the moon actually is. Not the moon filtered through 400 years of looking at it from the bottom of an ocean of air that steals the faint signals and blurs the rest. Not the moon as our instruments allow us to see it. Not the postcard version. Not the museum exhibit. Not the still silver disk that every culture in human history has watched in silence and called serene. The real moon. A world under continuous bombardment, getting hit every few minutes by something, scarred at every scale from microscopic to massive, absorbing over a ton of extraterrestrial material every single day with no defense mechanism of any kind. Silent, not because nothing is happening, but because there is no air to carry the sound, and we were always too far away to see the light. When Wiseman reported those flashes, when he used the word giddy, he wasn't describing a crisis. He was describing the specific joy of watching a belief system collapse in real time and something true take its place. The moon didn't change on April 6, 2026. We did. For 1 hour, the geometry of the solar system placed 4 human beings in the single most perfect observational position that has ever existed for seeing the lunar surface as it actually is. No atmospheric filters, no distance penalty, no phase restrictions, no light pollution. Just 4 sets of human eyes and a dark surface and the quiet, relentless violence that has always been happening down there. And they saw it. 5 flashes, 6 flashes, bright, sharp bursts against the Earth-shine-lit surface, each one a rock arriving from interplanetary space and converting its entire kinetic energy into light in a fraction of a second before going quiet forever. Here is why this matters beyond the science. Everything we are building toward, the Artemis surface missions, the lunar gateway, the permanent outpost, the long-term human presence on the moon, all of it is being engineered based on our understanding of that impact environment. And our understanding of that environment was built on data gathered from the wrong place, through the wrong medium, with filters so thick we didn't even know they were there. The Whipple shields being designed for habitat walls, the shielding mass calculations, the maintenance schedules for thermal blankets and solar arrays, the risk models that tell mission planners the probability of catastrophic failure over a 10-year mission. All of it traces back to flux numbers, and the flux numbers trace back to ground-based detection rates that, as of April 6, 2026, we now know are a floor, not a ceiling, a minimum count, not a true count. The engineering is not impossible. The shielding concepts work. Burying habitats under 2 or 3 meters of lunar regolith solves the micrometeoroid problem and the radiation problem simultaneously with material the moon provides for free. It's hard, operationally brutal, but it's solvable. What Artemis II gave us is not a reason to stop. It's a reason to be honest about what we're walking into. The moon is not the quiet companion it appears to be from your backyard on a clear night. It never was. It was always a world being sandblasted by the solar system at a rate we couldn't measure from where we were standing. Now we know. 1 crew, 1 hour, 1 geometry that will never be repeated exactly the same way. And the moon finally had to stop pretending. The question now isn't whether we go back. The question is whether we go back knowing what we're actually building into, or whether we let the postcard version of the moon convince us one more time that the view from here is the whole picture. Because it isn't. It never was. And somewhere up there right now, in the dark between impacts, the moon is waiting to see which version of ourselves shows up next.